unsuccessful offloading before making the decision. Once again, putting it into one piece, the AI or the machine learning model will have a large set of failing tasks and a set of succeeded tasks. Then we bring our task that we do not know which is better, offloading it or locally processing it. Then we let the AI model try to predict that and decide for us whether to offload it or not. This is in simple words. This is the use of AI power in order to solve the task offloading problem, task offloading decision problem. So this is for our first contribution, which is the idea. We just proposed the idea. We did not try it yet. We did not validate it via experiments. We're still familiarizing with the simulator. We are using Omnet, and we are trying to use Keras, which is a library for prediction. We are trying to match it with TensorFlow. We are still in the beginning. So we're just proposing the idea at the aim of giving us some insights by some good discussion. So for the second contribution, we try to evaluate the impact of mobile devices number. So we bring a lot of mobile devices, users, that are going to offload their tasks. We vary them from 20 to 100. We bring 3 edge servers. We selected tasks of like 1010 MIPS. MIPS stands for million instruction per second. So the tasks are characterized by this metric, which is MIPS. So task of also 1010, we did 2 experiments. So for the metrics, we used the received bits per second and the delay of edge tasks. The received bits per second is related to the edge server. So the edge server will receive a lot of tasks. So this will be a meaningful metric for that edge server. The second thing is the delay of edge tasks. When the edge server receives the task, it may introduce a small amount of delay. This is also calculated in our simulation. For the simulation environment, we just to make it clear, we took the 60 smartphones example to show you the general idea. So we brought 4 access points, 60 mobile users, and we have 3 edge servers that are available to make the calculation. Instead of making the calculation on your smartphone, you will send it to one of these edge servers. One additional thing that I did not mention is this one. It's called the orchestrator. What's the role of the orchestrator? The orchestrator is like the one who is responsible for managing the resources. So the mobile users, in fact, contact the orchestrator first. Then this orchestrator will be responsible for dispatching the task to the free edge server. It's responsible for managing tasks, in simple words. So for the first metric, which is the received bits per second, we got this results. We remarked that the first edge server, for some reason, received a lot of tasks. This is according to the orchestrator. We make it in the simple mode, default mode. So we did not apply a specific strategy. That's why we got these results. It's followed by the third edge server, then second edge server comes at last. For the second one, which is the last, for the delay of edge tasks, they almost got the same results. So we finished our presentation. Final thoughts. In this presentation, to summarize it, we saw what's cloud computing and what is edge computing paradigms. We saw task offloading decision for low latency and energy consumption. We saw that we showed that by making task offloading, we are optimizing our energy. We are making our lifespan, our mobile device lasts more than traditionally. Third one, we saw how we exploit AI to solve the decision-making problem across classification, across decision, whether to offload or not. The fourth one, we presented our contribution, which is the machine learning technique proposition. It's just a proposition. Then we saw the evaluating the change of devices number in kind of 2 methods. So that's it for today. Thank Thanks for your attention. Hope you got some ideas somehow, like edge computing, task offloading, AI to task offloading decision. Thanks.
Thank you, Mohamed. Now we have time for a question. Des gens qui ont des questions? Avez-vous des questions sur le sujet? Moi, j'ai... Ok.
Je vous remercie pour la présentation qui était très claire, très intègre. Mais, on ne sait pas que ce problème est ancien avec les services web. Les services web, web services.
Yes.
Web services, c'est une solution pour faire des calculs dans des machines autres que ce soit les smartphones.
Exactly. Web services is a special kind of like making a cloud computation. Web services generally use the internet, so they are cloud computing related. They use data centers, but they can be adapted to edge servers. Yes, web services is one of these applications. Exactly. It can be applied in the cloud and the edge servers. Yes, in your scenario, I guess it's going to be in the cloud.
On pourrait bénéficier de toute la recherche qui est derrière la technologie service web. Justement. Donc il y avait la résolution du problème de synchronisation, d'ordonnancement des tâches, etc. etc.
Yes, as we know, there are a lot of protocols, a lot of case applications. So, in my opinion, I'm not so sure, but as I read, according to my modest related work background, web services is just one of the categories of the applications that we can exploit to make exploiting it in the domain of edge service. Yes, but we can use others, so it depends on the application. Yes, you can. We cannot rely on making our tasks using the protocol of web services. Yes. Salam. It depends on the case, the application scenario. There are a lot of protocols.
D'autres questions? Très bien.
Donc, merci pour la présentation. C'est sur le point de envoyer les processus pour être exécutés dans le edge server. Oui. Vous dites que c'est pour, par exemple, économie d'énergie. Alors que, d'après tous les modèles mathématiques concernant la consommation d'énergie, c'est la communication qui consomme beaucoup plus par rapport au processing. C'est-à-dire, le but, comme c'est envoyer les données, envoyer les processus pour être traités sur le échelle, pour économiser l'énergie.
Yes.
Alors que le processing, il consomme beaucoup moins. Donc, d'ailleurs, l'énergie réservée pour le processus, elle est infime par rapport à la communication. Donc, il n'y a pas de problème.
As you were saying, is absolutely correct. There is a rule, if I remember correctly, it says that making a local processing of 10,000 bits equals sending 1 bit wirelessly.
Exactement.
So in this case, making local processing is correct. But we are talking about energy now, right? So I mentioned it before, but maybe I did not make it clear. As I said, logically, when you say that making the task involving switch, all of this will consume energy. So if we call it the consumed energy by offloading the task, you can get the idea that this will be bigger than making the processing locally. However, there is a problem. There is something that you may miss. So, you know that our smartphones have CPUs, right? These CPUs are by default, are not customized. But for the edge servers, there are totally a different mechanism. Some edge servers have specialized CPUs. So when you send it to the edge, the CPU there is better than yours, it will consume less energy. And even by involving the energy of sending you the task to the edge, even involving the switch and everything.
Le problème, c'est qu'au niveau des edge servers, le problème d'énergie ne se pose pas. C'est-à-dire, on ne peut pas dire que
I'm talking about the global energy consumed.
c'est au niveau des clients, au niveau des smartphones, au niveau des smart age, les services age.
For the
Donc,
smartphones,
le premier point. Le deuxième point, c'est le retard de communication.
for
Il est imprévisible.
For the smartphone scenario, offloading the task will definitely generate energy for the edge because processing data here. There are some. I will give you an example. Imagine you are making some filters or processing a video. If you send a raw data and make the processing at the edge, this will definitely consume less than making the processing on your local. Even with the rule of local processing versus sending one bit to the edge. This is a rule. I can confirm you that. This is, in fact, one of the benefit, one of the reasons why they involved the edge servers. So we should make sure, I can confirm you that, by offloading the task to the edge server, you will save the energy of your devices in a lot of cases.
Tout dépend du modèle mathématique utilisé
Yes,
pour
it depends.
ou le deuxième point sur le retard d'envoi des données.
Yes, there is a trade for that. But if I can tolerate, if the application has like 50 milliseconds, and you know that by sending your task to the edge is so powerful, it will make the processing and send you back the results before this 50 milliseconds. So here you will preserve the energy of your device, and you will fulfill the requirements of the application. You processed it before the threshold. In this scenario, offloading is the perfect decision.
Le C que vous voulez parler, c'est que dans le sens où la communication elle est parfaite,
Yes.
c'est que les données seront reçues par le service H.
Yes.
Mais dans le cas où les données ne seront pas reçues, c'est parce que c'est du transmission. Donc, comme la donnée, elle peut être arrivée, comme elle ne peut pas être reçue.
We are assuming a simple model that you have a set of mobile devices. We are not talking about a very dense environment. In a normal device, in a normal number of devices, you will not have a lot of interferences and the communication will go smoothly.
C'est juste pour conclure, donc sur les deux points que vous allez, le temps, le retard et la consommation d'énergie, il va falloir, par exemple, entamer une démonstration mathématique. Par exemple, le processing, le mode processing, c'est plus adéquat que le local processing. Dans le sens où l'énergie, elle sera, par exemple, préservée dans tel sens. Ou le deuxième point, on va gagner, donc on va gagner dans le temps, mais est-ce que c'est bien, la communication, elle est compatibilisée ou elle n'est pas compatibilisée?
Yes,
Le temps de communication.
it depends on the application.
Ah
But
oui, il faut les ajouter.
Yes.
Yes.
yes, this is called a trade-off. You can preserve the energy of your device by offloading it, but you are having the risk of getting the result back beyond the threshold of the application. In that scenario, yes, I may prefer consuming the energy of my device instead of offloading the task. So this is a trade-off.
Les solutions.
Yes. But if I can send the task and get the result back before this time, then I will be in the perfect form. For the global energy, I hope that you got my idea. Because they are specialized material. So they say there is another thing. You can make the idle state. The orchestrator that's responsible for managing the resources have the ability to turn off temporarily some edge servers. So instead of going to the cloud that's always consuming a lot of energy, you will have smart data servers with dedicated CPU that's built for energy problem alone. So now, and the orchestrator will turn off the edge servers and let like 2 or edge servers in this scenario.
Il faut prendre en considération, c'est que les dernières générations de la téléphonie mobile sont devenues très très puissantes, même équipées parfois de 4 processeurs.
Yes, in the case
Maintenant,
of mobile devices.
yes.
Yes, it's with the letter U, like in our computers. But for the Internet of Things, it still remains.
Je vous remercie.
Yes, thank you.
Est-ce que
Je vous remercie. Je vous remercie pour la présentation. Donc j'ai une question concernant les cloud computing. Donc, vous avez utilisé